If you've ever worked on any kind of software project, you will most definitely have written the same code more than once. And the same goes for any kind of game project. Or maybe even more so when we code games. And sometimes this is just fine. While we do want to minimize duplicate code, we also often want to spend more time adding new features than figuring out the most perfect way to structure our code. However, when we make a game with lots of things we can interact with, well, at some point enough is enough. And making parts of the code easier to reuse will also make the development process faster. And this is what this video is about. We're going to make components. More specifically, we will look at the slime enemy from my action RPG series and see how we can divide its code into more reusable parts. And now, let's get started. This is the scene and script for the slime enemy as it looks right now. We have a lot of things going on here. It moves, it animates, there's something about a knockback, and it can also die. And I just want to stress here that making all your enemies for your game like this is perfectly fine. You might want another approach if you hope to work in a larger team at some point or at a game development studio. But if you go through this video and don't feel this is the right thing for you, and you just want to finish your game, just continue like this. Getting your game done is always the main goal. But now, let's start with what a component is. Well, the word almost explains itself. It's a component, a part of a whole. When we talk about components in game dev, then we usually connect them to game objects, actors, entities, or something like that. I've seen various words be used for the same thing. But to not confuse this with a memory-optimized entity component system, I will stick with game object for now. Your game will have a lot of game objects. Our slime here is a game object. So is the player and the sword we can pick up. There's a lot of game objects in our game. What you might also have experienced in your own project is that a game object can be similar, but not really the same as other game objects. It might even have some things in common with one game object and other things in common with another. And this is one of the reasons we can end up with a lot of duplicate code when our game grows. One way to help solve this problem is to separate the game object itself from its behavior, and also its state, or at least some of its state. The behavior is then put into several separate parts, or components as we like to call them. The game object is then turned into a collection of components. A game object will then have some components in common with some other game objects, and others in common with other objects. When we build our game objects, we can then mix and match all the components we have to create exactly the game object we want. Now let's look at our slime again. What are the first components we can extract from this? Well, an AI movement component maybe. Yes, let's start with that. This will be a component that can be used if we want the game object to move without input from outside our game world. So no movement using a joystick, keyboard, or so on. We might also have a lot of enemies in our world with different types of AI. And this can be solved more than one way, but it isn't really the topic for this video. So for now, let's just assume that we would make a new component for each type of AI movement. Okay, so now we know what our first component should be. So let's create a new script for the component and call it Marker Movement AI C, because the slime in this project just moves between its own position and the position of a marker 2D. And then I'll also add the capital C at the end to specify that this is a component. Now let's go back to the Slime script and consider what parts belong to the movement. Well, first of all, we need two exported variables. One for the movement speed and one for the endpoint marker. So let's move these to the component. We also need a variable for the game object's start position and its end position. This is the two positions it will end up moving between. Now let's look at the code. Well, first we need to update the end and start position based on both the game object's position and the marker's position. And here we discover our first issue. How do we get the position of the game object? Well, there are a few ways we can solve this. We can either create an exported variable for it, or we can use the getParent or getOwner method. I'm thinking that getting the game object itself might be something that's done in a lot of components. So I really don't like making an exported variable for it. That will just add a lot of work when we need to assign the player to every new component. And well, I also usually don't like the getParent method, but in this specific case, I actually think that it's just fine. It does, however, come with the assumption that the component is always a direct child of the game object itself. But I think that in this case, this is a reasonable requirement. Now, what else do we need to move our slime? Oh sure, we need a method for changing the direction when an endpoint has been reached. And then we need a method for updating the velocity. Which reminds me that we also need an exported variable for the limit we compare to here. Here we need the parent again to set the velocity. So I think that instead of getting the parent every time we need it, I will just create a new variable for it and set it in the ready method. What else? Well, now of course we also need to actually connect it all in a physics process method. Where we'll just call the update velocity method and then move and slide on the parent. Now, if you're already sitting out there screaming at the computer about why I didn't do it another way, then please change this into whatever you think this component should look like. The goal really isn't to create the most perfectly architectured system, if such a thing even exists. Instead, we just want to divide our code into something that's easier to reuse right now. And as all other parts of our game, this code might also change more than once while the project grows. Now let's clean up the slime script by making sure that everything we moved to the new component is removed. And then we can add our new component to the slime, just like we add any other node. But now we have a problem. we used to give the slime its end position by adding it in the world scene. With this new component, we can't really do that directly anymore, because the component is encapsulated inside the slime game object. So how can we do this now? Well, again, there are multiple ways of solving this problem, and for now it really doesn't matter which one we choose. So what I'm doing here is using the parent node to get the marker to D by using the getNode or null method. Well, this worked just as expected. Or, well, if we hit the slime, it still moves. Do you know why this happens? In our slime script, we have an isDead variable that keeps track of whether the slime is dead or not. And before we moved the movement code into its own component, the movement was only updated if the slime wasn't dead. So yeah, this is something we need to fix. But I'll wait a bit to solve this. First, I want us to move the code for the slime's death into its own component. Or actually, I want to separate into two components. A HurtBox component and a health component. But this time I won't go too deep into what we're doing. If you followed some of my other tutorials and already have a setup like mine, then you can even try to do this yourself before moving on with this video. The HurtBox component needs an area 2D to take damage. And I actually think that that's the only variable we need right now. We also need a method to handle collisions with the HurtBox. In the ready method, we can then connect the area entered signal with our new method. In our health component, we just need a variable for the health, which in this case is just 1. And a method to adjust the health when we take damage, and also check if the health is 0 or less, because then the game object should die. If we look at the original code in the slime script, we can see that a lot of things happen when the slime dies. But other game objects might also have other things happen when they die. So we don't want to put all of this in our health component. Also, the health component needs to know when it should update. How can we solve all of this? Well, the problem is how to connect the different components without it being a too tightly coupled connection. For most purposes, a component shouldn't care how other components react to their behavior. And this sounds a bit familiar. It's just what signals can be used for. So in our HurtBox component, we can add a damage taken signal and emit it when there is a collision. And in our health component, we can create a died signal and emit this when the health is 0 or less. Now our components have told the world that something has happened, but other components have to take care of what this then entails. Let's then add an instance of the HurtBox component and the health component to our slime. And clean up the original slime script. We still need to connect all those signals. First, let's connect the died signal from the health component with the method that handles the slime's death in the original slime script. We could and should probably move most of this code here into other components as well, but I will leave that as an exercise. Now, let's look at how we can connect signals between components. Remember that we didn't want our slime to move when it's dead? So we need to connect the died signal from the health component with a new method in our AI movement component somehow. One option would be to connect the signals manually. But for me, personally, that would quickly lead to one big mess where I forget to connect some signals or maybe connect the wrong ones, especially as the project grows. What I like is to have the components themselves connect the signals they need. We can of course do this in the ready method. However, now we need to decide how to get the components that have signals we want to connect to. We could use the get node or null on the parent again. But then we need to make sure that the components are always called the same thing in every single game object we create. And again, this isn't something my brain likes. I like to create an exported variable for the components instead. Like here in the AI movement component, we can create an exported variable for a health component. And then in the ready method, I connect the died signal with the new method I created to handle this. To make the component stop when this method is called, I just change the process mode of the node to disable. Now, were there any other components that needed to react to other component signals? Well, yes, in our health component, of course. Here we want to connect the HurtBox damage taken signal. Now we just need to assign the exported variables, and then we should be ready to test and see if the slimes work as expected. Oh, but something isn't right here, and that's because I think that the collision layers and masks aren't really set up well here, maybe. To make sure that the slimes can only die from the player's weapons and no other collisions, then we can reserve a collision layer for the player weapon. And then we have to make sure that the slime's HurtBox only listens to this layer and that the player's weapon is on this layer. And then everything should work correctly. We can continue to divide our slime into more reusable components. But I don't really think that it makes sense to show you how I create every single one in this video. You will learn so much more by trying to make it yourself. But feel free to leave a comment or join the Megatech Discord server if you have any questions for this video or if there are some components you would like me to cover more in depth. I ended up with the movement, HurtBox and health component from previously, and then also an animation component and a knockback component. These are by no means the perfect example of components for this enemy. Maybe some parts would have been different if we'd used components from the start, or maybe not. What I wanted to show you in this video was a way to start moving the code you already have into more reusable components. As always, the project files for this tutorial is available for some of the tiers on Patreon. The last thing I want to shortly talk about is over-engineering. Remember that I said that the most important thing is to create your game. Well, this is why we need to be aware of getting stuck, because we can't find the correct solution. Remember that there really isn't one correct solution. Don't try to force components into every single part of your game, or even make them cover all parts of an enemy if it doesn't feel right. Practicing making components to learn is just fine. But when you work on a project, try to find the simplest way to make it work. If it seems too complicated or complex, then leave it. Use whatever you've done before. Remember, you can always come back to the same code later if you need to. Software development should always be an iterative process. And that was it for now. I hope you liked this video, and remember to like, subscribe, hit the bell and all that if you want to see more like this in the future. Bye!